In this session, we will talk about models and modeling.
Models and modeling skills are key to being a good architect. The product of the architect is a vision, it is intangible. The progression of models during the design lifecycle can be visualized as a steady reduction of abstraction. As architectural decisions are made and recorded, the range of options narrows, and the models become more specific. Eventually, the models become construction drawings and itemized budgets, and pass into the hands of the builders or developers. Part of the architect's role is to determine which views are most critical to system success, build models for those views, and then integrate as necessary to maintain system integrity.
Now let's talk about the why.
What is the purpose of models? A model is used to match the desirability of purposes with the practical feasibility of a system to fulfill those purposes. It can help the customer clarify abstract objectives through provisional and explanatory models.
Let's recall the definition of a model. It is an approximation, a representation of selected aspects view or collection of models.
It is a representation of a system from a related set of concerns.
It is also a viewpoint, a template for constructing a view. There are a few types of models we would use as architect. The first is models of form. These are physically identifiable elements of, and interfaces to what will be constructed. They are closely tied to particular construction technologies. Scale models can be used to build prototypes and proofs of concept. And block diagrams are used to show system interconnect diagrams, system flow diagrams, structure charts, class and object diagrams. Next, we have behavioral or functional models. These are used to describe specific patterns of behavior by the system. Threads and scenarios show a sequence of system operations, also known as use cases. Data and event flow models allow threads to be collapsed into more compact models. The next type is performance models. These are used to describe or predict how effectively an aspect of the architecture satisfies some function. These are usually quantitative and at a system level. These are also used for non-functional requirements and are products of science and engineering, particularly the formal methods. And lastly, we have data models. These are used to model what data does the system retain, and what relationships among the data does it develop and maintain. Entity relationship diagrams for relational databases is an example of this.
In data-intensive systems, generating intelligent behavior is a matter of finding relationships and imposing a persistent structure on the records.
Why do we use methods to model? The earlier definition stated in part that a systems architect is someone who uses a methodical approach. The use, transformation, and creation of method tools is seen as a sign of maturity in an architect. As a craftsperson becomes more mature in their practice, they grow in their facility to use the tools of their craft in different ways. This leads to generatively in one's profession and extends the current boundaries of practice. But one's use of methods should not be mechanical. I often get asked, must we always follow methods?
Methods provide structure to our thought processes to give us an idea of the next thing to do. Once you let go of the fear of not having the next thing to do, the structures created by your use of method in your mental muscle memory will take over. You will come to understand that the structure of the method which once empowered you feels restrictive. This is the breakthrough point at which your creativity is freed. But you really have not left method behind, it still informs what you do. I know this has been a very heavy session to cover the theoretical foundation of being an architect. Now that you know why we develop architecture models, and that you will need a method or framework to guide you, I will cover the more technical aspect of architecture frameworks in the next session.